Okay, so just to take a look at the answers to the questions I left you with, and that was to take the equations h to n and then complete the table below by matching each description given to one or more of the lines. Okay, so first of all we want a line with slope 2. Now in that case the best way to do this would be to remember that if the line is given to you in terms of an algebraic expression, you can first of all take the first coefficient of x and put it over minus b, so minus a over b. So in this case here we would be able to use that one. So in this case minus a over b will be minus 2 over minus 4, which will be equal to a half. So that's the slope of that line. Okay, in this one here we would have to manipulate this equation. So in order to get the slope of this line, I would suggest that you go for y equals mx plus c. So bring the y over to the left hand side. So y equals minus x plus 3. So you're simply swapping the position of x and y there, which gives me a slope here of minus 1. Okay, the next one, I would actually multiply out the brackets. So y is equal to minus a quarter of 2 is minus a half, because don't forget a half of 2 is 1 and a half of 1 is minus a half. So that's minus a half, and then you have plus 7 over 4. So in that case there, the slope is going to be minus a half. Okay. Next one. Again, x and y are together. So the easiest way to find a slope there is minus the first coefficient over the second. So minus 4 over minus 2, which is 2. This one here, again the x and y are together. So the slope of that is minus 1 over root 3. And here, the slope of this one is minus root 3 over 1. So now we've got everything we need in terms of the slopes. Okay, so which line has a slope of 2? So when we read down, we see there's only one with a slope of 2, and that's the line L. Next one, a line which will intersect the y-axis at 0, minus 2.5. Now keep in mind, if you're intersecting the y-axis, that means that you can remove x out of the equation altogether. So we're looking for the equation that when you remove x gives y a value of minus 2.5. Okay, but it's not going to be this one. Let's check this one here. Let's just take this out. So we've got 2x minus 4y is equal to 3. Now let's take out the x because we want to find out where it cuts the y-axis. So let's take out the x. That's going to give me minus 4y is equal to 3. Y equals 3 over minus 4. So it's certainly not that one. Okay, next one that it might be. Let's try intersects the y-axis at minus 2.5. Okay, let's try L. Let's take L out here and see what happens. 4x minus 2y minus 5 is equal to 0. Now, what do we want to do? We want to see where it cuts the y-axis, so we remove x. And that's going to give me minus 2y is equal to 5, which means y will be equal to 5 over minus 2. Guess what that is? Minus 2.5. So I have found it. So it's this one here. Again, it's L. A line which makes equal intercepts on the axis. Now, equal intercepts would mean the following, that the number it passes through on the x-axis would be the same as the number it passes through on the y-axis. All right, so that means that any time you allow x equals 0, y must give you a value, but when you allow y equals 0, the x must be the same value. So therefore what I would look for here would be an equation that already hints at the same x and y. Take equation h. Look at equation h. Equation h says x equals 3 minus y. Now let's just rewrite that. X plus y is equal to 3. So I'm just going to bring the x and y together. Now let's let x equal 0. Let's switch off the x. What happens? We get y equals 3. Okay. Let's switch off the y. What do we get? X equals 3. So this line passes through 3 on the y-axis and 3 on the x-axis. So therefore that answer there is H. A line which makes an angle of 150 degrees with the positive sense of the x-axis. Now the positive sense of the x-axis is this one, okay? This one here. That's the positive sense of the x-axis. So what would 150 degrees look like? Well, first of all, we know it would be obtuse. So just go back to what we said earlier on. So there's the x-axis. A line that would make 150 degrees would be something like that. Okay, 150 degrees with the positive aspect of the x-axis. Now, the tan of 150 degrees would therefore be the slope. So this is the new thing we had in the previous video, that a tan of 150, let's just do that, tan of 150, and that comes out as minus 1 over root 3. Now, is there any line up there that has a slope of minus 1 over root 3? Yes. Minus 1 over root 3 happens to be m. We've worked it out already when we rearranged the equation. And finally, two lines which are perpendicular to each other. Now, what does that mean? Well, that means that when you take the slope of 1 and multiply it by the slope of the second one, the answer must be minus 1. Or else you can say that m1 will be equal to the negative reciprocal of m2. Okay, so m1 and m2, they'll be fractions that have been turned upside down and their signs changed. So either one of those will allow me to do that. So which two lines are perpendicular to each other? Well, first of all, let's take a look at n and m, because they have symbols that are unusual. M has a slope of minus 1 over root 3, and n has a slope of minus root 3 over 1. Now, whilst they are reciprocals, the sign hasn't changed. So therefore they are not what we consider to be perpendicular. So minus 1 over root 3 and minus root 3 over 1, yes, they're reciprocals, but they're not negative reciprocals, so they are not perpendicular to each other. Okay, what about 2 times, there's a slope there, what about 2 times minus a half? What's 2 times minus a half? 2 times minus a half is minus 1. Bingo! When you multiply two slopes and get minus 1, you've got a pair of perpendicular lines. So therefore 2 times minus a half, they are perpendicular. So that will give me K and L. So that's just bringing it all together in terms of what we did from the first part of this lecture. Now to move on, I'm going to just do a quick review of all the formulas, and then I'm going to set you some work to do from your textbooks that you can do for class tomorrow. So first of all, find AB, 2 straight lines. What those 2 straight lines is, they want you to find the distance between A and B. So this is very much the distance formula. So always please write down the formula before you answer the question. It's amazing to know how many points are given for the formula alone without putting anything in. If you make a stab at substitution, you get even more marks. So never be afraid. Write down the formula first, then sub it in. Now, what do I advise you to do? x1, y1, x2, y2. And just sub them in exactly as they are. So x2 minus x1, that's 8 minus 5 to be squared. And substitute, don't do any calculations until the end. And then y2, which is minus 6, minus, be careful, minus minus 2, all to be squared. Now leave the working out to the next line. What does that give me? 8 minus 5 is 3, and 3 squared is 9. Minus 6 minus minus 2. Now that's minus 6 plus 2, which is minus 4, and minus 4 squared is 16. 16 and 9 is 25, and root 25 is 5. So there's how you use your distance formula. Okay, find the midpoint of the line segment AB. So I want to work out where the midpoint is. Now again, write down the midpoint formula. You add the x's together and divide by 2. Then you add the y's together and divide by 2. So again, the same thing. x1, y1, x2, y2. Don't be afraid to do it on the exam. Do it. And questions that you're going to be working on, do that. Mark them down as x1, y1, and x2 and y2. Okay, let's plug them in. Add the x's together. That's 5 plus 8 over 2. So don't forget, substitute before you calculate. So minus 2 plus minus 6. So minus 2 plus minus 6 over 2. So what does that give me? 5 and 8 is 13. So that's 13 over 2. And minus 2 minus 6 is minus 8 over 2 is minus 4. Now please, leave fractions as fractions. Don't turn fractions into decimals. Leave it as 13 over 2. Even though we know it's 6.5. Let's just check and see. 6.5 is here. Drop down. Bingo. And minus 4. So it works. Okay. Show that the line K contains the midpoint of AB. So now we've just found the midpoint as being 13 over 2 minus 4. So 13 over 2 minus 4. We've just discovered as being the midpoint of AB. Now we're being asked, Does the midpoint belong to K? Well, the line K is 6x minus 8y minus 71 equals 0. So what we're going to do is we're going to take that point and put it into the equation of K. This one will go in for x, and this one will go in for y. So rewrite the equation. 6x minus 8y minus 71 equals 0. Now do your substitution. 6 times 13 over 2 minus 8 times minus 4 minus 71 equals 0. Let's see. 2 into 6 goes 3 times. 3 13s is 39. 39 4 8s are 32. Good. So that's minus 32 again. Minus 71 is equal to 0. Okay. So am I writing that minus 6x is 39 minus 32 minus, no, that's not 0. Must be something wrong. Must be a misprint there. Show that the line K contains the midpoint of AB. Did I say take the midpoint in right? Midpoint, yeah, midpoint is there. There's the midpoint. Let's just get it again. It's 6.5 minus 4. So 6.5, that's 6 times 6.5, which is 39. Minus, that's 32, sorry, plus 32, that's it. 39, 32 is 71, minus 71 is 0. So that's correct. So it fits. So therefore, if ever you're asked to see, is a point on a line, you take the point, which is there, and you substitute it into the x and y positions of the line. And if the point is on the line, it will fit. It will give you a true statement at the end. Find the slope of AB. Now, first of all, how is AB presented? AB is presented as a pair of points. So the quickest way and the most efficient way to get the slope is to use the slope formula, y2 minus y1 over x2 minus x1. So take your values of y2, and again do the same thing, x1, y1, x2, y2, so that you don't put the wrong values in. Take your time. Minus 6 minus y1, which is minus 2, all over 8 minus 5. So what does that become? Minus 6 plus 2 is minus 4 on top. 8 minus 5 is 3, so there's your slope of AB. Leave it in fraction form, never go to decimals unless you're specifically asked to do so. And then lastly it says find the slope of K. Now where's K? Well, K, we're told from up here, is 6x minus 8y minus 71 is equal to 0. So what way is the line being given to me here? K is being given algebraically. So if I want to work out the slope, it's very simple. If the x and the y are together, the slope is minus the coefficient of x over the coefficient of y. So that's going to be minus 6 over minus 8, which is 3/4. Okay. And then it says, find the x and y intercept of the line K. So where does the line K cut the x and the y axis? Well, we could read it. We could say, well, it cuts there and it cuts here, but there's a bit of a pain because we're not too sure decimally speaking. It's not 12, it's in between 11 and 12, and this one is in between minus 8 and minus 9. So difficult to guess, and don't guess, work it out properly. Take down the line K. It's 6x minus 8y minus 71 equals 0. Now, if I want the x intercept, that means I rewrite the equation with no y. So 6x minus 71 is equal to 0. 6x equals 71, x equals 71 over 6. Leave it as a fraction. If x is 71 over 6, what did I say y is? Y is nothing, y is 0. So the point of intersection, that's important, the point of intersection on the x-axis is the point 71 over 6, comma 0, because when we're on the x-axis, y has a value of 0. What about down here? What about the y-intercept? Well, the y-intercept is that you rewrite the equation with no x. So minus 8y minus 71 equals 0. Minus 8y equals 71. So y is 71 over minus 8. And again, leave it as a fraction. So this point here has no x because it's on the y-axis. And the y-intercept is 71 minus 8. So there's your x-intercept and there's your y-intercept. And give back your intercepts as points. Don't give them back as just values of x and y. Give them back as a point. Okay, and lastly, is AB perpendicular to K? Well, if AB is perpendicular to K, what do perpendicular slopes do to one another? If AB is perpendicular to K, then the slope of AB multiplied by the slope of K should be -1. That's the test for perpendicular lines. All right, so let's go back. What's the slope of AB? The slope of AB, we were already asked there, slope of K is 3/4. So let's just write that in first. The slope of K is 3/4. Now, what's the slope of AB? Well, let's go back and get the slope of AB. Slope of AB is -4/3. Okay, so let's put that in there. Now, when I multiply -4/3 by 3/4, are they negative reciprocals? Yes. Take that slope here. Take -4/3, turn it upside down, what does it become? -3/4, change the sign, +3/4. So they are negative reciprocals. But watch what happens. 3 into 3 goes once, 3 into 3 goes once, 4 into 4 goes once, 4 into 4 goes once, answer -1. They are perpendicular. Okay, now I'm going to take this question from the book just before I give you some examples to do yourselves. On page 271, question 8. Because now that you're familiar with the line, and familiar with the equation, familiar with the slopes, and familiar with the x and y intercepts, they're going to ask you to utilize what you know with a little bit of algebra thrown in. What happens if we just give you one unknown in a situation? So here we've got a situation. 3x minus 4y equals 8 is the line M, and n is the line ax minus 8y equals 12. And they are two lines. If M is perpendicular to n, find the value of A. Now, what do we know about perpendicular lines? We know that the slope of M, if it's parallel to the slope of n, means that the slope of M is going to be the same as the slope of n. Okay, now let's write that down. First of all, what is the slope of M? Well, first of all, what way is M given to me? It's given to me in algebraic form, and the x and the y are together. So that means it's going to be used as -a/b. So minus the first number, -3, over the second number, -4, which is 3/4. Now, if these are parallel, then that has to be exactly the same as -a/b over here, which is minus the first one, which stays -a, over the second one, which is -8. So therefore, 3/4 equals a/8. Now it's very simple. If 4 becomes an eighth, if a quarter becomes an eighth, that means that the bottom has been multiplied by 2. So therefore 3 gets multiplied by 2 in order to give me A as a value of 6. Of course, another way to do that would be 3/4 equals a/8, cross multiply. 4a equals 24, a equals 6. I don't mind what way you do it, you use your own strengths in algebra to work it out. Okay, so the last thing I want to look at is if I give you the equation of two lines as a pair of algebraic expressions, and if I tell you that the two lines intersect, yeah, what point do they have in common? What is their point of intersection? And I think if you look at the bottom of this slide, you can see exactly what we're about to do. So if L1 is 4x plus 3y equals 14, and L2 is 6x minus 8y equals 71, the way in which we find our points of intersection is to solve them simultaneously. Pair of simultaneous equations. And we've dealt with these in the first 3 chapters of book 1. I told you umpteen times that you have to know the first 3 chapters of algebra inside out and back to front. Here's where we have algebra coming into coordinate geometry. So what do I do with this one? Well, keep in mind it's a pair of simultaneous equations. So that means that we're going to either eliminate x or y. Now, on inspection, y already has opposing signs. So therefore, I'm going to pick y as the term to eliminate. The lowest common multiple of 3 and 8 is 24. So I'm going to multiply the top line by 8 to get 3 up to 24, and I'm going to multiply the bottom line by 3. And that will give me a new pair of equations as the following. 4 eighths are 32x, 8 threes are 24, y equals 8 fours, that's 100, 1, 1, and 8 fours are 32, it's 1, 1, 12, okay? 3 sixes are 18x, 3 eighths are minus 24y. See what's going to happen here? They're going to cancel. 3 71s, well that's 3 and 21. Okay, so now go down the columns. 32 and 18, that's 50. Plus 24 minus 24, lovely, cancels. 112 plus 213, well, what's that going to give me? 5, 2, 3. So 50x equals 325, okay? Which means I'm now going to divide both sides by 50, and that's going to give me 32.5. 32.5 divided by 5, which comes out as 6.5. So x is 6.5. So that's my x coordinate. Now, how do I get y? Bring the value of x, which is here, bring it back to the original two equations and choose, let's say, the top one. Put 6.5 in here for x. So that's going to give me 4 times 6.5 plus 3 times y is equal to 14. 4 halves, 2. 4 sixes, 24. 24 and 2, that's 26. Okay, you should do these things in your head. Plus 3y equals 14. Now, bring the 26 over to the 14. 3y is equal to 14 minus 26. And 14 minus 26, 14 minus 26, I just don't want to make any mistakes, is minus 12. Lovely. That means y is minus 4. So what's the point of intersection? The point of intersection here is the point. You put these two back together again. The point will be 6.5, comma, minus 4. Always write your points in alphabetical order. What does that mean? X followed by y. Plenty of practice coming up in relation to those simultaneous equations. Okay, so I'm going to end here for today, and I'm going to leave you the questions on page 270 and 271. But will you please remember, these are in book 2. Okay, they're in book 2. I will put the questions up on Google Classroom just in case you didn't bring book 2 home with you. But it's in book 2, it's on page 270, 271, and I want you to fire ahead with those questions, and we'll come back and take a look at them tomorrow.